Okay, let's continue. So thus far, we've looked into wrangling and the basics of ggplot. Yeah, which are sufficient to create already relatively good, well-designed, informative visualizations. But where ggplot really shines is the second part, on styling, on all of the different options available to make the plot look prettier with relatively little work. And that's what we're going to be looking at in this next session. First, we'll be looking at how to store the plot in its own object, which can make coding with the plots easier. Then we will look at themes, pre-existing themes, which is a great way of making a plot prettier with just a single step. Then we look at customizing themes ourselves using the theme function. We look at scale, which is some scale functions, of which exist many to control the scaling of all of the dimensions in a plot. We look at labs, which is a super important part of visualizations, namely which we use to annotate the plot properly, so it can be read by the recipients of the visualization. And then we briefly look at how we can store the plot in a format that we can then use to put it into our presentations or a report, etc. Yeah, and then in this session, we'll recreate this plot here, which is similar to the one that you've worked on, but extends it. So we're not only looking at the aggregates across time, but we look now at the development across all of the quarters across time. We'll focus on one variable, and that is the income median. So what you see here is the income median from across sort of 2001 to 2017 for each of the 21 quarters. And what this plot tells you is that there's really a noticeable divergence in the sense that quarters that were already relatively had relatively high income, those quarters, or at least the average in those quarters, went up over time, whereas quarters that were relatively low in income, the incomes there actually decreased over time, right? So we definitely see a sort of more spread in income here in 2017 than we see at the beginning of the chart in 2001. Right? So there's really a growing inequality, not only one where really everyone gets richer and it's just sort of the rich that develop faster, but there's actually a noticeable decline in income in some of the quarters in Basel, in particular those that were already low in income at the beginning. All right, let's look at this. So the first thing is that we create a base plot. The base plot uses the Basel object, the Basel data set, and then in our statics, we define, we place year on the x-axis, we place income median on the y-axis, and we say, okay, please choose colors according to quarter. And then ggplot will automatically pull colors from its standard default color set and then add lines, or lines and points, because we require GM line and GM points, lines in these colors for each of these quarters. And ggplot also automatically adds the legend here. Right? And the first thing we do is we create this plot, but instead of plotting it, we're saving it into this myplot object. And when you do that, then you will actually not see a plot within RStudio. Nothing will really happen, because the only thing that has, or nothing will happen, or nothing visible will have happened, because simply the only thing that happened is that this plot code was placed within that object. If you want to see the plot, you then need to print or plot that object, which you can do simply by then running or executing the object. So if you then write myplot into the console, then you will get the actual plot shown in the bottom right of your RStudio environment. Yeah, and the cool thing is then that we can start to just simply add stuff to that, right? So we don't always need to work with the entire thing, but we can just then use the placeholder, right, the object containing that code, and expand on that. Yeah, and one thing we often want to add to our plot is a theme. Themes are aesthetic presets, and there are a bunch out there. There are a bunch in the basic ggplot package, but there are also other packages that provide interesting, really interesting themes that you can simply add to your plot, right? So this was our plot before, and now we can just say plus theme classic, and then we see a bunch of the aesthetic details of the plot changes according to whatever that preset is, right? We can add theme Excel to make it look a bit like old school Excel, if that is your flavor. You can use theme Economist, which comes from an extra package, to make it look a bit like The Economist, right? And you see, it's not just the coloring of the background, but also the legend has moved. It is now placed on the top and not on the right of the plot, right? Or you can use the theme of the Wall Street Journal, right? Or you can use theme minimal, which is one of my favorites, one that I often use because, yeah, it's a bit cleaner and it emphasizes the data rather than, for instance, the background. Yeah, so these are theme presets and they're super useful. Usually when I create a plot with ggplot, I add some theme, usually theme minimal, sometimes maybe also another one. And later on for maps, we see that we actually want to add a different one. But of course, we can control all of the elements that are set with the theme preset ourselves using the theme function. The theme function has a lot of different arguments, 87 arguments when I counted last, that it can use to control all of these aesthetic elements within the plot. And more than that, you're not actually supplying single values for each of these arguments, but you need to control every argument with a helper function, either element rect, line, text, or element blank. And each of these functions has a bunch of arguments themselves. So in the end, that amounts to 87 times a bunch of options that you can use to control what the plot looks like. And the way this works is that you take your plot and then add theme, and inside of the theme functions, you specify then one of these arguments in here, and then you assign to that the appropriate helper function, right? And the appropriate helper function for instance, the plot background, since it is sort of a rectangle, will be element rect. If we could try to control, for instance, how lines are presented, for instance, the lines that we try to plot in that we use to plot the data, or lines such as the axis, then we use element line. If it's about text, we use text, element text. And if we want to remove an element, we can use element blank. All right. Yeah, let's use that to change a few things in our plot, right? The first thing we want to do is put the legend to a different location here to the bottom, which here is very useful to us because we only have a relatively narrow space for our figure. By having the legend right of the figure, right, we have very little space to actually see the data. So by placing the legend at the bottom, we get a lot more real estate for our data. Yeah. Then we see, however, that the legend isn't shown sort of perfectly, right? Some of this is cropped. And we see here one, which is probably Wettstein, is cropped off. And of course, we can control these elements or everything here in order to fix that, right? So we can say, okay, please remove the legend title, because that's probably not important. Everybody will know that these are quarters in Basel. So we can remove that, giving us a bit more space for the legend using element blank. So we say legend title, please let that be element blank, which means that's removed. Then we can also control the text. Right, and say, okay, we see the text isn't fully fitting here. We just make the text a bit smaller. Say legend text. We control that with element text and say, okay, please let the size be 7, which is smaller what it currently is, and then everything fits. Yeah, what you can also do is just save your theme settings within a separate object. Right, we can take this theme function in our settings and place that within an object, and then we can take that object and add it to our plot. And this is super helpful if you have a standard set of settings that you want to apply to your plots. You just save them one within an object, and then you can add them to any plot that you want to be styled according to your settings. One important note, these self-created themes, they're not functions, but they're objects. So you have to omit the, you should not place parentheses behind your own theme object. Right, then oftentimes you want to manipulate the scales. Scales most naturally means sort of the scaling of the x-axis or the y-axis. You would use that, for instance, to, I don't know, have a log transformation or other kinds of transformations, or to control the ranges, right? Maybe you want to show only the years 2005 to 2010. Then you would use a scale x function and then set limits within that function. But scales are also used for all other dimensions. And in ggplot, really colors or size or opacity are also understood as dimensions the same way that x and y are dimensions. So they're also scale color functions, scale size functions, scale alpha functions that you can use to control these dimensions and change them whatever way you think is best. Yeah, and what we want to do here is use different colors. So ggplot has a fairly decent default color set, but it may not be the best. And one good alternative color set is the Viridis color set, which you increasingly see out there, at least in scientific circles. And it's used because it has a number of attractive properties. The main one being is that the colors are not only different in terms of their color value, but they're also different in terms of their sort of, is it luminosity or their brightness, right? So all of these colors are different on a dimension going from sort of very bright colors to very dark colors. And this is helpful because there are people that can't see all of the colors the same way you can. And is also helpful because sometimes you want to represent something in black and white, and then you can still see differences between the colors. Yeah, so Viridis is really a good standard set. And because it is a good standard set, there's actually a dedicated function within ggplot. There's a scale color Viridis D and C, which you can use to color discrete and continuous variables placed on dimensions. And here we use scale color Viridis D because color is selected according to a discrete variable, quarters. And by just adding that, then the quarters will be colored according to this other set, right? And then we get these different colors. But yeah, this is clearly not ideal yet, because anytime you use color, you actually want color to represent something, right? Colors should always be used sparingly. And when you use it, you really should be thinking about what do I want color to represent? Right? And one way to use color here is to have color actually represent the initial level of income. And that's what we will be doing now. But in order to do that, we need a little bit of wrangling first. So in ggplot, anytime you want to control the order of discrete variables, you need to explicitly define them as a factor and make sure that the factor levels are exactly in the order you want ggplot to interpret that variable, right? So in order to make the colors be according to the initial level of income, we need to add a little bit of wrangling before we get to the ggplot part, where we arrange everything according to year and income. So then within every year, we will have sorted everything by income, and then create a factor quarter. And since everything is already arranged according to income, the factor levels will be chosen according to the levels of income. And the result of that is then that, as you can see here, quarters with a lower starting value in terms of income will get the darker colors, and then quarters with a higher level will get the higher levels, right? And that is clearly a better use of color, because now color really helps you understand the different levels, right? Where each of these quarters is starting out at, right? And we also, another benefit is we see that the legend is then labeled accordingly, or the labels change according to the factor, right? So now things were ending on Wettstein, and now they're ending on Bettingen, because Bettingen happens to be the quarter that had the highest level of income in 2001, and Altstadt Kleinbasel, the one with the lowest income. right? So from this now, you can also already read out the order of income levels in 2001. Right, we're pretty close to the plot that we want to create. What we definitely need to add is labels, and the importance of labels cannot be understated. Labels is really a super important part of plotting. You always want to have intuitive labels for X and Y, but if possible, you also want to add titles and other kinds of information. Depends a bit, of course, on the format, right? In a scientific article, you always have a sort of a figure description, right? And you can put a lot of information there. But maybe in a more sort of business-like report, you actually do want to use title and subtitle to provide the information that you would otherwise have in sort of a full plot annotation as in a scientific article. Yeah, in ggplot, you can add these things using the lab function. You simply say plus labs, and then inside of labs, you can control all of the different elements. You can decide what's the label for the x-axis, y-axis, what's the title, what's the subtitle, and what's the caption, right? And there may be even more settings. Yeah, so that's the plot that we wanted to create. The last thing we often want to do is save it, right, in a format that we can reuse for a presentation or something else. And ggplot has a function for that. It's ggsave. There are other ways of doing this, but ggsave makes it easy to save a figure as, say, a PDF or a PNG. You simply need to define the name, and you need to add the extension. You provide the plot that you want to save. So this is where it's handy to have the plot stored in an object firsthand. If you don't define this, it will just take the current plot from the plotting window. Then you decide on the device, which is really what is sort of determining the format that the plot will be stored in. So if you want to save a PDF, we choose this to be PDF, or if it's a PNG, we use the PNG device. We can define the folder where it goes and the width and the height and all sorts of other things that control how the final PDF or PNG or whatever format looks like. Obviously, you can store it also as a TIFF or as a JPEG or whatever.